Hello, my name is Bradley Alisea, and I am the open source community manager for the Rockware Initiative. I'm also a senior contributor at the Open Worm Foundation and founder of the Orthogonal Research and Education Lab. And I'm going to talk to you today about Reconfigure from all over, the case of interdisciplinary open source communities. So the first thing I'm going to talk about is this big idea of spontaneous interdisciplinarity. So this is the idea that you can bring people together from different disciplines spontaneously into working groups and then accomplish great things in an open source context. So our question here is, how do we bring members of different disciplines together in open source communities to solve common problems? And this has a lot of practical implications. For one, it helps us to better solve what they call wicked problems, which are large, multidimensional problems with a lot of different sources of expertise needed to solve them and address the issues within them. These are often, embodied by large social coordination problems. So that's one example. The other example is what C.P. Snow called the two cultures. And what he sort of proposed is that you have science and you have the humanities, and that they speak these mutually exclusive languages. And they also have a lot of beliefs that don't necessarily overlap. And so you want to build a bridge between those two mindsets to sort of exploit the best of both worlds. And so that's maybe what we're trying to do in a lot of open source communities. It isn't as obvious because we don't think of our open source expertise, that diversity, as being these separate cultures, but they actually are, as we'll see. So there was a paper published in 2013 called The Rise and Fall of Interdisciplinary Research, the case of open source innovation. And they looked at different open source initiatives that were highly collaborative. And they found two trends. The first is that high involvement exchanges, which are exchanges that are, where people are deeply invested in their exchanges and projects. Those projects tend to decline pretty quickly. You have people from different disciplines or different perspectives. Those projects tend not to be sustainable. If people are working at low levels of involvement, it's more sustainable, but then again, people understand less about what actually is going on in the project. The second trend is that collaborations tend to decompose into parallel and disconnected groups. And so this is what the term decline means. And so you can see in this citation network that you see how fragmentation occurs. Early on in a project, there's a lot of citation of a lot of different sources from this network. And over time, it fragments so that participants are selectively sort of interacting with the things that they're familiar with. So there's this process that goes on. And the way research problems in communities are organized, particularly modularizing research processes, which we'll see how that works, is key to mitigating these kind of trends. So to fight this sort of fragmentation, we need to think a little bit outside the box. And we have to understand that community networks disconnect and reconnect over time. We have seasonal and random fluctuations of people onboarding and leaving. So people might work on a project over the summer or over the holiday, and then they leave. And so we have to account for all those sorts of fluctuations in addition to this sort of natural decay. The second trend is that community networks tend to be heterogeneous, which I mentioned previously. Whether they also will tend to form self-contained cliques over time is up to the community. So in this network, it's fragmented into two cliques, which are highly connected subnetworks and people who are talking to one another who have maybe similar disciplinary backgrounds, but there's no cross-communication here. So what is the structure of networks for open source collaboration? Maybe if we dive a little deeper into that, we can understand this better. So open source communities are transient, flexible, and what we call heterarchical, which means it's not necessarily hierarchical. No one's directing this stuff from the top down. It's heterarchical, where power tends to be distributed in different ways, especially these large interdisciplinary projects. So the term hierarchy simply means that your members or your nodes can be ranked in a number of different ways. You have some project leaders, but you also have other people with expertise who tend to lead certain aspects of a project. If you have a low barrier to entry in your network, that means that what they call the preferential attachment rule, which often drives a lot of this fragmentation, is generally not applicable. And open source networks have multiple functions and objectives which reinforce this hierarchical aspect. So what I'm saying is that open source networks tend towards hierarchy, but there's a lot of things in terms of project management and other types of forces countervailing to that work against it. So these are examples of hierarchical networks here versus hierarchical networks. This is a hierarchy versus a heterarchy. And another example of this where you have this structure of a tree versus the structure of a flat system. So how do we redraw network structure over time based on identity to find these optimal expertise reconfigurations? So now we're talking about taking expertise in the community and reconfiguring it somehow into different ways. So we have different things going on over time. How do we reconfigure this without fragmenting this community? And you end up talking only to the people who you would have talked to, who know the most about what you know. So this is a growing network. This is an animation. It just shows how networks grow and doesn't necessarily show how they reconfigure, but we'll get into that in a little bit. So there are a couple of strategies here. One is selective disconnection with intentional interconnectivity. So this is a way to measure interaction, and this is something we can understand. So in this case, we kind of look at like the cliques in a network, and we see people entering the community, and we can actually monitor this clique formation. And then if we can understand it like this, so this person is joining these groups, and these two cliques are skeptical of letting this new person in. If we can understand the structure a priori, then we can correct for some of the things that it selects for. And so in this case, we see a connectivity matrix where we can actually monitor these connections and mitigate this sort of clique formation. Another example is reconfiguring complex, looking at reconfigurability from another context, not just the statistical one, but where we actually look at complex academic institutions, and we think about how those can be reconfigured in a similar way. So how can we leverage community expertise from a wide range of campus units or topical interest areas? The reason I bring this up is because this is what I do. And of course, our organizations that we're kind of thinking about are academic in nature. So this is a interconnection switchboard from an old phone system. And the idea is, you connect to different areas given like a set of instructions. In this case, it's much more self-organized. So, we have to think about what a open source academic organization looks like. In a typical campus, this is an example of a typical campus. You have a lot of sub-functions that are running all the time. You have transportation systems, campus events, social interactions, building scheduling. Those are all things in a campus, in a physical campus, that affect how it operates and how people interact with one another. So if we can model those and understand those, we can better mitigate some of these effects. We also have alt academic communities. So this is a community that's entirely virtual, and we have members who have different topical interests, and their topical interests overlap in some ways, but they generally don't surface in meetings, in virtual meetings, or in presentations or otherwise. And so if we can draw out a map of those interest areas, we can better understand how to organize people, or better how people can interact better to maximize things, interdisciplinary interests that might arise or needs to innovate. So which contributors and disciplines are your greatest source of contributor activity and greatest source of variation here? So when an individual connects to this network, they have to connect in some way. And as I mentioned, the different connection rules might exist in different contexts. So let's take the example of the input of contributor from discipline A. Which kind of niche expertise do they bring into the community? Do they act as a conduit? Do they bring more contributors from discipline A, or do they act as their own sort of interdisciplinary unit? And how long do they contribute for? What's their intensity of contribution? What is the magnitude of their contribution history? All these things can drive this sort of a network, shape this network in different ways. So I'm going to get into an example now of reconfigurability of disciplinarity. And so this is an example of a project that's a year-long project. And the idea is that we're going to use these principles to kind of understand what these groupings look like and how they change over time. So I've been talking up to this point about various practical examples and various theoretical examples. Now I'm going to put some skin on the project aspect of it by showing how this project unfolds over a year. And so we start in January, we go to April, and then July, September, December. Each of these months are milestones that occur in the community, and we're going to look at how we can reconfigure our community to match the needs of this project. So the first one we have, this is a diagram I call optimists and pessimists. You see these two different emojis that I use here. You have the optimists who are really kind of, one skill set, and the pessimists who are kind of another skill set. And, I like to mix them just to show the variability here. But so in this project, we have a number of different things that we need to achieve. From January to April, we're going to focus on biological lab expertise. We have all these people coming into the community. They're connecting to the community in the form of a network. They're forming these networks. How do we exploit this sort of diversity, and how do we exploit these connections to maximize our time here? So we start with biological lab expertise. We make a call. We identify people of different skill sets who have different things that we need to achieve this goal. So biological lab expertise, we're able to achieve this in January to April. Then we flip to statistical modeling, and we see that we have a new set of groupings for different contributors. Then we move to philosophy of science. Now, this is a very different skill set. This is July to September. And so now we have a different set of contributors. And then finally, we have software engineers, and this goes on from September to December. And of course, we have different different set of contributors there. So the idea here is we need to find different mixes of contributors. We need to think about the plan, the project. We need to think of a timeline that optimizes their availability. And so all those things are key in this reconfigurability. So thank you for your attention, and I hope you found this talk useful. If you want to join our communities, you can join each one of those communities as our launch passes for the, I think, our Slack channels. And so if you join up, you can have discussions in our community, and you can become one of these experts who get reconfigured into different projects. Thank you.